Assalamu alaikum wa rahmatullahi wa barakatuhu, and a very good morning to all of my dear student. Today we'll discuss on the topic translational and rotational motion. A rigid body when acted upon by a force. This is a rigid body. If a force is acted or pushed, then the body will move in a linear motion or translation motion or rectilinear motion or in a straight line. If a force is applied, then the body will move in the direction of the force. This is called the translation motion. And if we want to rotate a body, then we will apply force here. Okay, then the body will rotate like this. This is called rotational motion. Now, if you want to move a body, rotate a body, or we want rotational motion, then the body will move along a pivot point, that is a fixed point or fulcrum. Then we apply force here, then the body will rotate either in clockwise or in anti-clockwise. Okay, now that is called the turning effect or moment of force. So in this chapter, this one is very important. And what do you mean by moment of force or turning effect? Look at the formula. Moment of force is also known as the torque, T-O-R-Q-U-E, and this is a torque equal to force into perpendicular distance. The formula is moment of force equal to, that is torque, is equal to force into perpendicular distance. Now, a torque is equal to the product of the magnitude of the force and perpendicular distance of the line of the action of the force from the axis. Now look at this. This is a wheel. We want to rotate this one. So here is the force, and this one is the distance. This one is the distance. Okay. So here force and distance. This is the perpendicular. So perpendicular distance. This distance and force. The force into distance from the axis of rotation. That is called the moment of force. Okay, or torque. Force into perpendicular distance. What is the SI unit of torque? Unit of force is Newton and unit of distance is meter. So SI unit of moment of force is Newton meter. Okay. Now here, look at this. This is a door, opening of a door. For example, this is a door. Okay. This is a door here. This one is a door. This side is a hinge. Here, hinge is there. Okay. Or pivot point or fixed point. So the handle is at this corner. We'll put it at that end. So we are applying force in upward direction. Then the body will move. So force is applied here. So distance between the fixed point, pivot point, or the point of application, this is called the distance. Okay. Now when you are applying force here, the door will open. Okay. Here, if you apply force here, the door will not open. We'll discuss later. Look at this. Here, this is the hinge. So this is the handle. This is dotted line indicate the pivot point or axis of rotation. So if you apply force here, okay, then this door will open. So this is force, and this distance is called the perpendicular distance. Okay, perpendicular distance. If this distance is less, then we need more force. Here, more force. Here, if you apply force here, then the door will not open. Okay. So if we calculate the torque or moment of force, for example, we need 50 the moment of force, we need 50 Newton meter. 50 Newton meter to open this door. Okay, so if the distance is 10 centimeter or 10 meter, for example 10 meter, then we need only 5 Newton. Okay, if this distance is 10, and then how much force we need? 5 Newton, then 5 into 10, 50. So with 50 Newton meter, this door will open. But if this distance is decrease, if this one is decreased, so to get 50, we need more force to make up this one. Okay. Now, here another example is spanner or wrench. Spanner. Okay, so this is a handle, and this distance, this is called the distance. Okay, perpendicular distance. So we apply force here, either here or in that direction. Then if we apply force here, then the body will rotate like this. Okay, so this is force and distance, force and perpendicular distance. So torque is F into D. More the handle, bigger the longer the handle, we need less force to get the torque, to get the moment of force. Okay, so the body will either move clockwise or anti-clockwise. So if you apply force here, then the body will move like this. So this is anti-clockwise. If you apply force in upper direction, the body will move in that direction, clockwise. Now, on what factor the moment of force depends? We know the formula for the moment of force or torque is F into perpendicular distance. So the moment of force or torque is depends on the force and perpendicular distance. More the force, more will be the turning effect, and more the distance, more will be the turning effect of torque. Okay, so all are, this is directly proportional to the force, magnitude of the force and magnitude of the perpendicular distance. Clear? Now what are the condition that no moment of force, the moment of force or torque is zero? Torque is zero. Simple, either force equal to 0, then we get 0 into D, 0, or distance equal to 0. Okay, if force equal to 0, if we apply no force, then this body will not rotate. Or if the distance is 0, here, if you apply force here, perpendicular distance, here you are applying huge amount of force at the hinge. Look at this. This is the door. So if the handle put it here, then you can easily open the door. But if the handle is put it here, and this is the pivot point, will this door will open? No. How much amount of force you applied, the body will not rotate or not open. This door will not rotate. Why? Because the distance, perpendicular distance is 0. Okay, and if this is the door, one more condition is, if this is the door, this is the opening, this side is a handle. If you apply force in that direction, huge amount of force, is this door will open? No. Okay, here this is if you are applying force here, upward direction. So if somebody apply at that direction, okay, the body will not open, the body will not rotate. For example, here look at this. Here this is the door opening, here the handle, this side is a hinge, this side is a handle. So if you apply a force, then this door will open. Okay, here this door will open. But if you apply a force in that direction, here, okay, did you see this? Here, huge amount of force in that direction. Will this door open? No. So this is the third condition, that if you apply a force on this axis, that in that direction, then there is no moment of force. Clear? So very important. Now earlier said that if the body will rotate in only two directions, either clockwise or anti-clockwise. Clockwise or anti-clockwise. For example, this is a ball. If you apply force here, then the body will move in that direction. That is anti-clockwise motion. this is a ball. If you apply force here to rotate this one, the body will move in that direction. This is called clockwise direction. So this is the two way to rotate. Okay, now clockwise moment of force is always negative, and it is inward. It is inward means close, and anti-clockwise moment of force is always positive, and it is outward. For example, this is a tab. Here, wait. Here some examples are given. Here, look at this. If you apply a force in that direction, then this is anti-clockwise. Anti-clockwise means positive, and this will be open. The tab will be open, and to close this handle, this tab, we will apply a force in clockwise direction. So if you apply a force in clockwise direction, then this tab will close. Okay, here also look at this. Tighten the cuff. To tighten the cuff, we need tighten means we need to apply a force in clockwise. Tighten the inward means close, clockwise movement. Okay, if you rotate it in clockwise direction, then this will be tight or in tight. Okay, now here to open this one, we need to rotate like this. Like this. Okay, open and close like this. Okay, did you understand this one? So clockwise moment of force always negative, and it is inward, that to close or tighten something. And anti-clockwise moment of force is always positive, and this will be outward. That means something will open. Okay, and one more thing, very important, the moment of force is a vector quantity. Clear? Hope you have understood. If you have any kind of question, then you can ask. Write in the comment. Thank you.